like to look at one more example of, in this case, marginal cost, and we're going to see actually what it can tell us about exact cost and how those two can compare sometimes. So here we have a company that manufactures automatic transmissions for cars. Here we have the total weekly cost in dollars for producing X transmissions is given by C of X equals 50,000 plus 600X minus 0.75X squared. So that's our total cost function. Part A, I want to find the marginal cost function. Remember, marginal just tells us to take the derivative of, in this case, our cost function. So I'm looking for what is C prime of X. In this case, we don't need to rewrite any terms. We can just go ahead and use our power rule. Derivative of 50,000, that's going to be 0. Here I should have 600 minus 1.5 times x to the first power. And there's our marginal cost function. Nothing more that we can really do with that part. So we have our marginal cost function. Part B says we want to find the marginal cost at a production level of 200 transmissions per week. Now in these types of problems, X is always going to represent the number of units. So here it says X transmissions. So here we're just going to take 200. We're going to plug that in for our X value. So I am looking for, in this problem, what is C prime of 200? So here in this case, okay, I'll just plug 200 in for X. So that'll be 600 minus 1.5 times 200. Here we should have 600 minus 300 would give me 300. So again, if I want to think about what this is telling me, in this case, is telling me that the total cost, remember that we're talking about marginal cost here. Marginal cost is the derivative of the total cost function that we had up here. So that's describing the rate of change of the cost function. So this is saying here in this particular problem that our total cost is changing by, and we said a number can change either by increasing or decreasing. Here, because our derivative was positive, we can say that our total cost is increasing by about $300 per unit. So if I wanted to just quickly talk about what this means, I would say, okay, well, the total cost is increasing by $300 per transmission. Now, one thing I didn't mention here, and I should have, is remember this all depends on your production level, how many transmissions or how many units you're producing per week or per day or per month. So I will just briefly mention here at a production level of 200, we'll just say units per week. If I change that to say 400 units per week, then my number is going to change. I may not have a positive 300 anymore. So this is saying the total cost is increasing by about $300 per transmission. So again, if I want to think about this, if I decide I want to make another transmission, I can look at this and say, well, it's going to cost me about $300. And this is really nice because we can use it to estimate the exact cost of the next transmission. So suppose I wanted to find the exact cost of producing the 201st transmission. So I only want to know how much does the 201st transmission cost for me to make. Well, now if I take C of 201, that might be a good start. Remember, C is my cost function up here. But this is going to tell me the total cost of making or manufacturing 201 transmissions or 201 units. So it's not just the 201st, it's all 200 that came before it. So what I would need to do in this case then is I'm going to have to take the total cost of all 201 units. I'm going to subtract then the total cost of the previous 200 units, and I'll talk about how to find that in a minute, and that would give me the total cost of only the 201st unit. So this is what I've got to find here. Now the total cost of 201 units, that's really C of 201. We said that up here. We said C of 201, that'll tell you the total cost of making 201 units. The total cost of making 200 units, well, that's going to be C of 200. So I need to find these two values first, find C of 201, and then subtract C of 200, and then that'll tell me the total cost of that 201st item. So I have a bit of work cut out for me here. First, I need to start by taking 201 and plugging that into our cost function, which that was given up here. We said it was 50,000 plus 600x minus 0.75x squared. So here I'm going to have 50,000 plus 600x, so 600 times 201, minus, and let me just make sure I get this right, minus 0.75x squared. So minus 0.75 times x, that was 201 squared. Now let me grab my calculator here so I don't make a silly mistake. 50,000, plus 600 times 201 minus 0.75 times 201 squared. And I ended up with $140,299.25. So that is just this number. That is just C of 201. I still need to find C of 200, so I'm going to do the exact same thing. I'm just going to change my x value now to 200 instead of 201. So 50,000 plus 600 times 200 minus 0.75 times 200 squared. This time, if I plug all this into my calculator, I should end up with $140,000 even. So I've got the two values that I said I wanted, this 140,299.25 and 140,000. Now I can go ahead and take those and plug those into this equation that I set up down here. I'm just going to subtract the two. So $140,299.25 minus the 140,000, and this time I get back $299.25. This is the number that I was looking for. This is the total cost of just the 201st item. So that was kind of a lot of work. I had to plug these two separate numbers in, and then I had to subtract, and boy, I sure do wish there was a easier way to do this problem, or to at least get close to this number. And I say, hey, hold on a second. Hold on. What about this guy up here? We said C prime of 200 was equal to 300, and that's pretty darn close to this $299.25. And I can think about this here. And hopefully this makes sense. If we look back at our interpretation, we said total cost is increasing by $300 per transmission. So that's, we said there, if I wanted to make one more transmission, it would cost us about $300. And that's exactly what happened here. So we can, on occasion, use marginal cost to help us determine the exact cost of one particular item. Now, one thing I'll mention before I wrap this video up is that this only works because we picked a number that was relatively close to 200. So when we set this up, let me take a step back to part B. When we set this up, we said our X value was 200. And then we chose the 201st transmission. This sort of approximation only works because those two numbers are pretty darn close to each other. If I had chosen, say, the 210th or the 220th or the 250th, something that gets farther away, this approximation becomes less and less accurate. So my approximation becomes not particularly good. So in order to maintain a good approximation here, we need to make sure that the exact cost of the item that we're trying to find is relatively close to the marginal cost that we found back in part B.